Namaskar. In today's lecture for the microwave electronics, we will discuss the microwave devices employing the effect of Faraday rotation in ferrite materials. In our previous lecture, we have discussed the Faraday rotation effect in ferrite materials. According to the Faraday rotation effect, the plane of polarization of the plane TEM wave rotates as it propagates along the ferrite slab, which is magnetized with a static magnetic field along its axial direction. So the effect of rotation of plane of polarization is called the Faraday rotation effect, and also we have discussed that this effect is a non-reciprocal one, means the plane of polarization will continue to rotate in the same direction if we reverse the direction of wave propagation. So now in today's lecture we will discuss this effect of Faraday rotation, and we discuss the device, namely gyrator, or sometimes also spoken as Gyrator, which is based on this Faraday rotation effect. So it is defined as a two-port device that has a relative phase difference of 180 degree for transmission from port 1 to port 2 as compared to the transmission from port 2 to port 1. So the gyrator may be constructed in two ways. Number one is called a gyrator with a twist section, and secondly a gyrator without a twist section. So first we discuss the construction of gyrator with a twist section. So in this figure we have shown a two-port device in which the input and the output ports, namely port 1 and port 2, these are rectangular waveguides, and these two waveguides are connected with the central part of waveguide, which is a circular waveguide. This is a circular waveguide, and these input and these two output waveguides, these are rectangular waveguides. Both input and output rectangular waveguides are in the same orientational planes, and the input rectangular waveguide is connected with the cylindrical waveguide at the input end with a 90 degree twist section. Also in the middle part of the cylindrical waveguide there is a ferrite slab which is magnetized by static magnetic field B0s, and its length is selected in such a way so that it can produce a 90 degree of Faraday rotation in the counterclockwise direction. Both the ends of the ferrite slab are tapered. These both ends, these are tapered so as to reduce the direct reflections of the incident wave from both the directions. Now the construction of this device can be understood in such a way. Suppose at the input end the direction of the electric field polarization vector is in this direction as shown in the figure. So when it passes through the 90 degree twist section, its plane of polarization is rotated in a counterclockwise direction as shown in this figure, and when it passes through the ferrite slab section, then a further rotation of then a further rotation of 90 degrees will be caused in the counterclockwise direction by the Faraday rotation effect. So when this wave reaches at the port number 2, its plane of polarization will be rotated by 180 degree, and it has the correct polarization to transmit from port 2. Now if we reverse the direction of propagation back from port 2 to port 1 as shown in this figure, So in passing through now again the Faraday rotation section, due to the non-reciprocal property of the Faraday rotation effect, the Faraday rotation will be caused in the same counterclockwise direction due to non-reciprocal property. But when it passes through the twist section, 90-degree twist section, the next rotation will be in a direction so as to cancel this earlier rotation. So the resultant polarization as compared to the incident at the input end. So when we compare the two polarization directions at the input end from port 1 to port 2 and as compared to from port 2 to port 1, the differential phase shift of 180 degree can be easily understood at this input end. So this device has the property of a gyrator. That is, it produces a relative phase difference of 180 degree for transmission from port 1 to port 2 as compared to the for transmission from port 2 to port 1. So this is the gyrator with a twist section. Now we discuss the construction and working of the gyrator without a twist section. So in this figure, this is the design in which the two input and the output rectangular waveguides, these are connected with the central circular waveguide. Both the input and the output waveguides does not have any twist section, but the input and the output rectangular waveguides have 90 degree of orientational planes. So if the inconvenience of having the input and output rectangular waveguides oriented at 90 degree can be tolerated, then this design without a twist section can also be constructed. So in this wave design also, in the central circular waveguide there is a ferrite slab with both the ends were tapered so as to again reduce the direct reflections of the EM wave, and a static field B0 is again produced in a direction so as to produce a 90 degree of Faraday rotation in the clockwise direction. So the working can be now explained as shown in these two figures. If at the input end the electric field of the incident wave is shown here in the figure, and when this wave passes through the Ferrite slab section, then its plane of polarization will be rotated by 90 degree due to Faraday rotation, and when this wave reaches at the port number 2, then this wave has the correct polarity to transmit from port 2 here. Now if we just reverse the direction of wave propagation back from port 2 to port 1, then again in passing through the Faraday rotation section, due to non-reciprocal property, the plane of polarization will again continues to rotate in the clockwise direction. So a 90 degree additional rotation will be produced here. So at the input end at port number 1, when this wave reaches, again this wave have the correct polarity to pass from port number 1, and now if we compare the differential phase shift for transmission from port 1 to port 2 and as compared to the transmission from port 2 to port 1 at the input end, again it can be easily seen that the relative phase difference is 180 degree. So again this device also possesses the properties of a gyrator. So in this way we can explain the construction of a gyrator in two designs, one with a 90 degree twist section and secondly without any 90 degree twist section. So gyrator can be used in microwave benches in which a relative phase difference of 180 degree is required. So we will use this device in the construction of a 4-port circulator. Thank you.